Hey guys, we're on Unit 11. This is day 4, and this is our intro to the unit circle. Okay, so a unit circle is something that we use in trigonometry, and it is a circle that has its center at the origin and has a radius equal to 1 unit. So it's a very tiny circle. Okay, hence it's called the unit circle. 1 unit is a unit. Okay. So in number 1, it says, consider the unit circle shown below with an angle theta drawn in standard position. Okay, so this red angle is what the angles we've been talking about. Okay, and this angle theta here is our first quadrant angle, and they are asking us to find an expression to represent cosine theta. Okay, so on day 1 of our notes, we talked about cosine theta equals, hold on, let's talk about SOHCAHTOA for a second. Some old horse caught another horse taking oats away. That's SOHCAHTOA. That ka is representing cosine, and that cosine theta equals your adjacent side over your hypotenuse side. So as we are reading from this angle called theta, okay, we put our little stick person there, that our adjacent side is actually this piece here called x. Okay, and our hypotenuse is here. And that has a length of 1 because the hypotenuse is actually the radius of our unit circle. Okay, so it's a lot going on in there. All right, so we're going to rewrite cosine theta equals my adjacent side, which is labeled x, over my hypotenuse side, which is labeled 1. And we have to realize that x over 1 is the same thing as x. And so cosine theta equals x. Okay. So from here on out, this x of this point is now known as cosine theta. Okay. Now we're going to figure out what y is equal to. Okay. Hopefully you guys can see already. All right, so sine theta, according to SOHCAHTOA, is O over H. It's your opposite piece over your hypotenuse piece. Okay. And so when we replace our opposite with the opposite from our picture, which is y, since that side here that's labeled y is the opposite from us, okay, over our hypotenuse, which is 1. And so we're going to say sine theta equals your opposite, which is y, over your hypotenuse, which is 1 again. And so we're going to clean that up a little bit and say that sine theta equals y, because y over 1 is the same thing as y. And so this y here in our point up here on the unit circle now has sine theta as the y coordinate. Okay? And so from here on out, if we ever want to figure out the coordinates of any point on the unit circle, all we have to do is look at what the angle is, and to get the x coordinate, we will type in cosine of that angle. To get the sine coordinate, we type in y. To get the y coordinate, we type in sine theta, so sine of whatever the angle is. Okay? So here we go. Next one up in part C says find an expression to represent tangent theta. Well, remember, tangent theta equals your opposite over your adjacent, according to SOHCAHTOA. Okay? And our opposite side is y. So we're going to say tangent theta equals our opposite side, which is y, over our adjacent side, which is x. Okay? However, I'm going to fix that up. Tangent theta equals y, which is really sine theta, over x, which is cosine theta. And so that is how we now define tangent. Okay, that is the division of sine and cosine. Okay. Part D, if every point on a graph can be represented by the ordered pair x comma y, then every point on the unit circle can be represented with cosine theta and sine theta. Okay, and so here we have an example. If theta equals 50 degrees, find the coordinates rounded to the nearest hundredth on the unit circle where the terminal ray of the angle intersects the unit circle. So just to give you a visual, okay, but if this is our unit circle, and we have 50 degrees, which is looking like an angle of about here, maybe. Okay, this is 50 degrees. We want to know the coordinates of this point right here on the unit circle. Okay, and so in order to find the coordinates out, all we have to do is cosine theta, comma sine theta. Okay, they're alphabetical, easy to remember. And so because our theta is 50 degrees, all we have to do is replace our thetas with 50 degrees and type them in our calculator. Okay? What comes out for cosine of 50 is 0.6427 ... And sine of 50 typed in our calculator is 0.76604 ... Okay? They said to the nearest hundredth, so that would be 0.64, comma 0.77. Okay? And there's the coordinates on the unit circle, because remember, this is only one unit out this way. So as we go up, we go in, and we haven't gone all the way up to 1 here. And so now we have those coordinates on that unit circle, where your angle, your terminal ray, intersects that unit circle. Okay? And now we have those coordinates. Number 2. The terminal ray of an angle theta drawn in standard position passes through the point 0.6, 0.8, which lies on the unit circle. What's the value of sine theta? Well, remember that this is your cosine and this is your sine. And so we can say sine theta would equal 0.8. Okay. Part B, what's the value of cosine theta? And that's the first one. And so we'll say cosine theta equals 0.6. Okay. In part C, they want to know the value of tangent theta. So remember, tangent theta is your opposite over your adjacent, which we said our opposite was y over our adjacent, which was x. And y is really sine theta, and x is really cosine theta. So we have sine theta, which is 0.8, over cosine theta, which is 0.6. And if we divide the two, that comes out to be 4/3. Okay. Part D, it says, in which quadrant does theta lie in? All right. So we could go ahead and think of a couple things. Okay. But if we were to graph this point, 0.6, so over just a little bit and up just a little bit, okay, you end up with in quadrant 1. Okay. Part E says, what is the value of theta to the nearest degree? Okay. So if we ever have to solve for theta, we have 2 ways of doing it. Okay. We could say theta equals sine inverse of 0.8, or we can say theta equals cosine inverse of 0.6. Either way, whichever one we type in, we end up with theta equaling 53.1301 ... which to the nearest degree is 53 degrees. All right. So hopefully that stuff makes sense. We're going to talk a little bit about more on the unit circle on the back side. I'll see you guys there.